Okay, we're ready for you to start, Dan, whenever you are.
Okay, thank you very much. Hello, everybody. My name is Dan Lipsa. I'm an R&D engineer with Kitware. I'm going to present a large-scale visualization with ParaView. So just a few words about Kitware at the beginning, and then I'm going to introduce ParaView, tell you what it is, various flavors it comes in, and also the basic data types that are used inside ParaView. And then we're going to look over basic usage. So I'm going to introduce a few common filters. I'm going to talk about selection. So this is going to be done as a series of small hands-on exercises. So if you can download ParaView or you have a recent version of ParaView on your machine, that's going to be useful if you want to follow along. And in the end, I'm going to cover visualization of large models. Luckily, this is very similar with just interacting with the program on your local desktop, with a few differences I'm going to highlight in this presentation. So Kitware is an open source software R&D company. We have 5 core areas of expertise: computer vision, data and analytics, HPC and visualization, medical computing, and software process. So mostly focused on visual computing. In these areas, we write and maintain libraries and applications together with our collaborators and with the open source community. And we also help customers to build custom solutions based on these libraries and applications. If I would be to just name one program that is the most widely used, that would be definitely CMake in the software process group. This is the most commonly used program for building C++ applications. So I'm in the HPC and visualization group, and this is the group that works on ParaView. We do collaborate between groups, but each group has its own sort of focus. So to follow along, I'm going to use ParaView 591. You can use a slightly older version as well. So introduction, ParaView is an open source BSD3 scalable multi-platform visualization application based on the visualization toolkit. This is the library that has all the visualization algorithms. BSD means that commercial companies can download, modify the program, and sort of incorporate that in their own commercial applications, so there are no restrictions. We find releasing BSD software, open source software, useful because that helps us work with customers. It removes any concerns they might have. ParaView supports different processing paradigms. Besides the serially processing algorithms or computation, it also supports distributed computing, MPI. This is the type of parallelism that runs on the HPC machines. It supports shared memory multiprocessing using a small utility, SMP tools inside VTK. It also supports GPU processing using VTK-M. This is a separate library that implements a lot of the same visualization algorithms that VTK supports, but it is focused on GPU processing and also shared memory SMP as well. But it's a larger library, so we use both SMP tools and VTK-M. ParaView also supports, besides the regular OpenGL rendering, it supports physically based rendering that's implemented in OpenGL. So this is a different way computing lighting that gives you better results. It gives you more realistic results. And also integrate ray tracing libraries such as Intel Osprey or NVIDIA Optics. So if you download the latest binary from ParaView's website, you can turn on Osprey if you are running on an Intel machine, or if you have an NVIDIA graphics card, you can turn on Optics. You'll get similar results with both these ray tracing libraries. ParaView has an open, flexible, and intuitive interface, and it has an extensible and modular architecture based on open standards. So we use this modular architecture to build ParaView in different flavors to, I guess, solve slightly different problems. So ParaView runs on the desktop. This is the application we're going to use in our tutorial. But it also runs on the web. So we have different variants here. We have Visualizer, so ParaView Visualizer. This is an application where only the UI runs inside the web browser. We try to duplicate the UI that you have on the desktop, but you have a ParaView server running that does all the processing and visualization and then sends the image back to Visualizer. We have another version, ParaView Glance. This is a visualization application that runs entirely in the browser. It is based on VTK.js. This is the equivalent of VTK running inside the browser. So it supports some of the same visualization algorithms and similar data types as VTK, but it's a subset of VTK. So VTK, it's much larger. ParaView supports scripting using Python. So instead of using the interface to build your processing and visualization pipeline, you can do the same thing in Python. And this allows you to produce images and produce visualizations in batch mode. This is helpful if you have a series of images that you have to process in a similar way. A script will help you do that. You can build a ParaView script using the help, but also we have inside ParaView, we have a very handy tool that allows you to trace everything you do in the interface. And in the end, as you build your visualization pipeline, and then you stop tracing, you get a Python script that you can run sort of outside of ParaView, and you can modify and do your processing this way. So this is the easiest way to build these scripts, and then you can sort of check the help when you need to modify that script. ParaView supports these cave environments where you project the image on different walls. Also, it supports VR, these VR headsets as well. ParaView was built for parallel processing, distributed memory processing, so it runs very well on all these large HPC machines. ParaView Catalyst, I think this was mentioned in the introductory talk, is a library that gets linked with a simulation to facilitate in situ processing. So the idea here is that saving data on disk is very time consuming. So instead of saving the data and then doing the analysis and visualization after the fact, this is called post-processing, you do the analysis and visualization while the simulation is running. So this is called in situ processing. You don't save any data, and because of that, you potentially process higher resolution data, and you could devise insights that otherwise are not available because it takes too long to save your data from the simulation. We also build a lot of custom applications from ParaView. So the idea here is ParaView is a general purpose visualization tool. It supports a lot of processing, but it's also complex. So it can be complex to use. You have literally hundreds of algorithms that you can choose from, and knowing how to combine them takes experience, and you have to understand what every algorithm does. So with a custom application, and also the UI is quite complex, or can be complex. So with the custom application, you simplify the UI and you customize it for a specific domain. So you will have only a specific set of processings for that domain. The interface is going to be a lot simpler, and users will be able to use that without knowing the whole ParaView. So, this is an example application we built, which is focused on processing LiDAR data. So ParaView is used by academic, government, and commercial institutions worldwide. It's downloaded about 135K times per year. It won a number of awards. It can be used for all data ranges. You can use it on the desktop, but also you can use it on these large HPC machines for literally billions of cells, structured or unstructured. ParaView uses these following types, basic types, to represent data inside ParaView. These are VTK data types. So underneath ParaView, or everything that's represented and processed in ParaView uses VTK. So all these are optimizations that can save memory or can speed up algorithms. You could very easily represent everything as unstructured grid, but that will take a lot of memory and it may slow down processing. So the uniform rectilinear grid, we call this VTK image data, can store only the origin, the extents along each axis, and the spacing for one cell. All the other cells are the same. We store a little bit more for a non-uniform rectilinear grid. So here we store the origin, we store the extent, but also we store the spacing for each cell along each axis. So we store more. Moving to the right, for the curvilinear grid, we have to store the point position for each point, for each node. Then for polygonal data, you store not only point positions, but you store topology information. This is the links between the points, representing cells or elements. These are used to facilitate interpolation, that is, finding out values in between points. And unstructured grid is similar with the polygonal data. The difference is that unstructured grid can store 3D cells. Polygonal data stores only 2D cells. So polygonal data is used to represent meshes. This is what we use to send to the graphics cards. Unstructured grid can represent 3D cells as well. We have a number of other data types, but we won't go over them. So to get more information, to learn more about ParaView, you can use the help menu inside ParaView. So I'm going to switch to ParaView and take a look at that. I have here ParaView 5.9. So getting started with ParaView, this is just a short document, PDF document that teaches you in a couple of pages, 2 or 3 pages, 2 pages, the basics about ParaView. And then ParaView guide, it's a comprehensive guide. You can use that as a reference to learn how to do a specific thing. It's a good resource to search things on. We recently moved that on the web, so right now this is online. It used to be a PDF document, so this is makes a big difference. It's a lot easier to browse around and search things. Readers, filters, and writers references. So these are all the readers, filters, and writers available in ParaView. These are available in the binary version. So if you might have additional filters or readers that were not compiled in that case, they won't be in this list. So always check the source. Certain readers are not compiled in because they need external libraries. So this may require additional work to make those libraries compile on all the platforms we support. So we just didn't get around to do it, or we didn't have funding to do it, or we didn't have customers interested in having that in the binary. So if you have some readers that are not available, for instance, I know one that's not available, but it is in the source reader for PDAL data that uses PDAL, the point cloud processing library. That's not in the binary. We would like to add that to the binary, but we just didn't get around to do it. ParaView tutorial, this is a PDF document and also a set of slides. This presentation is based on the ParaView tutorial. We give a whole day courses on the ParaView tutorial. This is a very useful resource. You can go through the PDF document, and you have a number of examples. You can sort of go through them by yourself. So it's a useful resource if you want to learn more about ParaView. There's a number of additional tutorials at this link. This examples visualization is 4 examples that you can click on them, and you get them loaded into ParaView. So you can see the pipeline. You know, I can see a bug here where the font is too big, but that might be because I have a high resolution display laptop. I think I reported this. So hopefully we're gonna fix it in the next version. Okay. So I reset this. I'm waiting. Okay. All right. ParaView website. It's a collection of all the resources I talked about. ParaView wiki. This is a collection of documents that have some important information, more advanced information. Some of the information there might be outdated, but still a very useful resource. ParaView community support. This is points to the discussion board we use. This is called Discourse. So that's definitely a great resource. If you start using ParaView and you have questions, do ask your questions on this discussion board. Most questions get answered, and you can learn a lot. I do follow that, and you can learn a lot just by sort of following the discussion there. There are some very knowledgeable people answering even sort of more difficult questions. But yeah, if you have like simple questions, you get stuck in something, you're definitely going to get help. And then this points to the release note for the current release of ParaView. I guess the release of ParaView that you are running. Online tutorials, online blogs. This is a blog that we as Kitware keeps, and it's tagged for ParaView. So you'll see only new developments in ParaView. So if you are interested in that, definitely take a look at this. So bug report takes you to GitLab to report bugs, and we do offer professional support and training. Okay. The about dialog is also useful. It tells you in particular what graphics card you are using. on these laptops, you have usually 2 graphics cards. You have a less demanding graphic card, like the Intel one, and you can have a more demanding one, like the NVIDIA one. You can see which one ParaView is using. And there are ways in Windows of telling Windows to use one or the other. Yeah. Okay. So I'm gonna go over, as I said, a number of examples, and I'll show you some common filters that will get you going in processing your data. So first, the user interface is like any other desktop application. We have a menu bar that lists all the commands, toolbars that lists only the more commonly used commands. Here on the left, it's the pipeline browser. So the pipeline, it's the series of algorithms that you're going to execute to produce, to analyze, and visualize your data. We call the algorithms, we call them filters, or we call them pipeline objects. And then you have 2 panels here, the properties panels. The properties panel lists properties for filters, so you can change the properties on each filter, and that will modify their processing. This is how you customize your visualization and your processing. You'll have also display properties. These are associated with the pair filter and view. And then you have view properties that are associated with the view. We have also an information panel that gives you information about the data produced by the current filter. So you select a filter, the information panel is going to give you information about the data produced by that filter. So it gives you like the number of points, the number of cells, the bounding box for the data, and so on. What type of data it is. So let's go over a number of examples. You're going to start very simple. So we're going to create a cylinder from the sources menu. So sources are filters in ParaView that just create the data. We use them for testing, and sometimes you can use them for sampling your data set as well. So let's create a cylinder. I'll switch to ParaView. So sources, I think this is a geometric shape. Yep, and let's create a cylinder. Notice button here applies is highlighted. So ParaView works this way. Every change you make, every new filter you create, or every parameter you change, you have to hit apply. This is because potentially some of the operations are very long, so we don't want to change things, and sort of your program is suddenly doing a very time-consuming processing, and you don't know what's happening. So you always have to press apply after each operation. So we press apply, and we see our cylinder here. It has six sides. Okay. So what can you do with how you can interact with your data? In our case, with this cylinder, you can use the left button to rotate. Middle button, I think, is pan, and the right button is zoom. If you are like me, working on a laptop, you don't have middle and right buttons. These are quite useful, but lately I've been working on a laptop a lot, so I don't have a mouse. ParaView does help you in this context. You actually don't need a mouse with 3 buttons. You can use modifiers like the shift and the control modifiers to do pan and zoom. So I think for me, shift is pan and control is zoom. And you can set this up. By default, it's not set up this way. You can set this up using edit settings and then camera. So you can see here 3D interactions. I have rotate, left button, and then shift plus left button, that's pan, and control plus left button, that's zoom. Yep, so you can set things up the way you want, and you can work fairly well on a laptop as well. You can hold on X and Y. So if you hold on X, you're going to rotate around the X axis, hold on Y, and then drag. You're going to rotate around the Y axis, and Z the same way, rotate around the Z axis. Yeah. So hold on Z and then drag your mouse. If you zoom, so if you zoom this button here in the toolbar, it resets the camera so that your data fits nicely inside the window. This is similar, but if you have several data objects shown in your view, you can just reset one particular object. This button sort of zooms around the rectangle you draw. So draw a rectangle and it's going to zoom there. And this aligns your model with the axis. So I think that's the default one. Z minus Z means Z pointing toward the screen, toward you, toward the viewer, plus Z means Z pointing toward the screen, and so on. So minus Y means Y pointing toward the viewer, the user, yeah, and so on. You can rotate the model left or right, and also you can you have a center of rotation, and you can show that. In our case, it's going to be hidden, so we can make the model transparent using the display properties, opacity, yeah. And then you can show center or hide it. And then you can pick a different center somewhere, yeah. And then you can, rotation is going to happen around that center. You can reset the center to put it in the middle of your object, okay. So these are the main camera controls that you have in ParaView. Okay. I think I just created by mistake a new view. I'm gonna, let's see. So I'm gonna switch back to the presentation. So how do you change the cylinder? You've seen it has 6 sides. You change the cylinder by modifying properties inside the cylinder. So you can change the resolution. So properties of the cylinder, change the resolution. Nothing happens. You have to click apply. Yep. And you see the cylinder is going to be a lot more rounder. Can make the opacity 1 again, so that cylinder is going to be opaque. Yeah.
Hey Dan, there was a question in
Yeah.
the chat about, is there a way to create a cylinder along a different axis? So rather than being aligned with Y, can you make it aligned with X?
There is a transform. Yep, there is a transform filter that allows you to rotate your data. So that's how you do that. Yeah.
Right. So you would apply a separate transform filter to change that.
That's right. That's right. That's right. So there's no way, as far as I've seen, but you can apply a transform filter, and that that's true for. This is like a little bit of modeling functionality in ParaView, so you can change the orientation of your data if you sort of put together several data from different places. You can move your data around, orient it differently using the transform filter. Yeah. Okay, so next, so we talked about the need to always press apply when you create a new filter or when you change properties. If you change a property and change your mind, you can click reset. That's gonna get the previous value of the property, or you can click delete to delete a filter. Filters are, I guess, if you are very strict, are objects or processing algorithms that get an input and produce an output. Sources, they just produce an output, they don't read anything. Readers read data and produce an output, so read a file from disk and produce output. We have a new concept in ParaView called an extractor. This is similar with the writer, so you can add them to your pipeline and you can save, let's say, images at a certain point in your pipeline, or you can save data at a certain point in your pipeline. You can do it directly with the mouse as well, but the sort of the driving reasoning behind this was to create these extractors to run in situ. So you can create your pipeline, you create your extractors, and then you can generate a script that you can run in situ while your simulation is running. So this way, let's say you would save an image for every time step, or you would save like a smaller data set, like a feature that you extracted while your simulation is running. So those were properties that we talked about. The resolution of the cylinder, that was a property associated with the filter. Display properties, on the other hand, are associated. So you see here you have three different groups of properties. So we look at the filters. Display properties are associated with both a filter and the view the filter is shown in. So this allows you, for instance, to have the same filter shown in a certain color in one view and in a different color in a different view. So these are the display properties. So you can change colors, change the representation, for instance, show surfaces, or just show a bounding box, or show just the edges of the model. Can modify the opacity and the specular light. So let's try that. Let's change the cylinder, and let's change it, make it a different color. So this is the edit. This is the edit color map. In our case, we don't map scalars with colors. Our cylinder doesn't have any scalars, so you can just change the color, make the cylinder red. So this is in display properties, coloring, edit. Notice this is also duplicated in the toolbar. That's the same dialog. Yeah. The next group of properties, these are the view properties, are associated with the view. An important property here associated with the view is the the axis grid that shows you a axis along the tree XYZ that shows you the bounding box of the object. So you can see the size of your object. So we turned on the axis grid. As you can see already, we have a lot of properties. Filters can have a lot of properties. You have display properties, you have view properties, and we try to help with this complexity by grouping properties in two categories. One are regular properties, and the second category are advanced properties. These are maybe properties that you would use less. So if you want to see more properties, you can press this toggle button. Let's look at so notice in the view properties, you just have a few of them. You press the toggle button, you'll have a lot more. So that's one way. A second way would be to I'm sorry. To type a few letters from the property. So for instance, if you look for the specular light, you type a few letters and you would see the properties that match those letters are these are filtered, and only those properties are going to remain. So you can change the specular light, change the specular coefficient, and you can see specular light showing on your cylinder. The trick here is you have to make sure you remove these letters, otherwise you'll have your properties filters. So a property that you are looking for, it won't show. For instance, I want to get rid of this axis grid. I don't have the axis grid. It happened more than once for me. I said, where did my properties go? So you have to remove that filtering string, and then your properties will come back and remove the axis grid. Yeah. Okay. So we did the specular exercise. We've seen these properties, axis grid and opacity. Another feature that ParaView has is it allows you to change the background using this color palette. So for instance, if you want to print your visualization and put it in a paper, you would want a white background. So it's good to use this this control instead of changing the background, because this changes not only the background color, but it changes several additional colors that are associated with the background. So you can see this in the edit settings and then color palette. So you see a list of colors that are associated with the background. So all these colors are chosen so that they fit well together. We have the background white, interactive widget, selection colors, edges, and so on. So all these have to fit together. You cannot have a black or like a dark background and then maybe dark text as well. You won't see the text. So okay, ParaView supports undo and redo for both operations you do on your pipeline and for the camera. We can try in our ParaView. These are listed in the toolbar. So undo, you see the color palette was changed to have the default background. Undo, the axis grid appears, and then redo, axis grid disappears, the background gets white again. So these are the undo and redo for operations on the pipeline. And we have something similar for camera. So maybe you had like a point of view that was useful. You can do undo, and it goes back to show you all the camera values that you had previously. Okay. So you can create data using sources, but most common is you're going to read data from disk. We support a long list of formats. We always improving readers in these formats.